Welcome to this explainer. Look, we hear the phrase shifting left and securing the software development lifecycle in theory all the time, right? But today, we're ditching the theory. We're going to transform the abstract concepts of secure software development into a concrete tactical playbook that you can literally implement today. We're focusing on the exact tools, the activities, and the daily habits you need at every single phase of development. By the end of this, you're going to walk away with a highly actionable checklist to seriously fortify your own software pipelines.
All right, so here's our playbook for today. We'll kick things off with the blueprint, then head right into the coding trenches, followed by stress testing and launch. After that, we'll set up the watchtower, and finally, we'll tie the whole shebang together with the automated engine. Okay, let's jump straight into phase one, the blueprint, covering our requirements and design.
So this perfectly illustrates our activity map. It's a strict 6-phase pipeline. And the goal? We are going to systematically inject security protocols into every single step, from the initial requirements all the way through to maintenance. We are absolutely abandoning that old, painful idea of bolting security on at the very end. Instead, we're building a continuous life cycle where security is a native feature of every stage. Let's actually break down that very first step, requirements.
Now, in the requirements phase, you're already mapping features to standards like the OWASP-ASVS, and you're noting regulations like GDPR or HIPAA, right? But here's the kicker. We also need to write abuse cases. These need to perfectly contrast with your standard use cases to anticipate attacker behavior. Think about it. When your product team writes a use case stating user uploads a profile picture, your security requirement needs an abuse case right next to it saying attacker uploads a file containing malicious JavaScript. Defining your data risk classification and compliance obligations right out of the gate ensures they actually inform the design rather than popping up as a nasty surprise during a compliance audit months down the line.
Moving right along into the design phase, this is where threat modeling frameworks like Stride or PASTA really take center stage. They help us document trust boundaries, thoroughly review the architecture, and properly design our key management. You really have to explicitly map out every single place where data crosses from a trusted context over to an untrusted one. And honestly, this is the exact moment to decide how your components will be hardened. What ports are going to be exposed, what encryption is required, and crucially, where are your encryption keys going to live and who exactly gets access to them.
All right, moving on to phase two, the coding trenches. Let's talk development.
We've got to begin with SAST, or Static Application Security Testing. This should be running in every single IDE and CI pipeline to automatically flag unvalidated inputs or to make sure you're actually using parameterized queries instead of just string building. SAST is phenomenal because it analyzes your source code without even needing to execute it. It's literally spotting dangerous patterns that match known vulnerabilities while your developers are typing. So, alongside your peer code reviews, SAST ensures that basic hygiene, like output encoding and input validation on untrusted sources, is enforced way before the code ever leaves a developer's machine.
Now, to put things into perspective, the NPM ecosystem alone contains well over 2 million third-party packages. That massive number emphasizes exactly why software composition analysis, or SCA, is absolutely critical for checking your log files against CVE databases. Let's face it, modern applications are basically built on third-party code. SCA tools scan your dependency tree and instantly alert you to known vulnerabilities or license compliance problems. And the absolute best way to utilize SCA? Integrate it directly into your pull request workflow. Just imagine adding a vulnerable dependency, and your SCA tool automatically drops a warning comment on your PR before a human even has a chance to review it. That's a real game changer.
And when it comes to secrets, listen. The golden rule is 0 secrets in source code. Once a secret hits GitHub, even for a single second, it's compromised forever. That means you must use pre-commit hooks, like Git Secrets or Trufflehog, to scan for API keys in milliseconds before they ever reach a remote repository. You absolutely cannot rely on developers just remembering to exclude their .env files. You need automated enforcement. A pre-commit hook runs instantly on the local machine, and if it spots something that looks like an AWS key or a database password, bam, it completely blocks the commit. As for the secrets your application actually needs to run, integrate a manager like HashiCorp Vault early on, and make sure you're rotating those dev credentials constantly.
That brings us to phase 3, stress testing and launch. This is all about testing and deployment.
Here's where we deploy DAST tools, Dynamic Application Security Testing, like OWASP, ZAP, or Burp Suite. The goal here is to aggressively attack our staging endpoints, exactly like a real hacker would. DAST actually sends malicious payloads at your running application.
It's looking to see how your app responds in real time under pressure. And since tools like OWASP Zap can be fully automated right inside your pipeline, you get this continuous, aggressive testing of your application's boundaries without lifting a finger.
But to achieve truly complete coverage, we also run IAST, Interactive Application Security Testing, during functional testing. IAST actually instruments the application from the inside out to find flaws that SAST and DAST might just completely miss. Meanwhile, we've got fuzz testing. This throws pure chaos at your app using tools like AFL or libfuzzer. It's just hurling unexpected, malformed inputs to see if you can force a crash or uncover undefined behavior. And of course, aggressively scanning your container images for OS-level vulnerabilities and validating authentication and rate limiting on your APIs, those are non-negotiable steps here.
Then, during deployment, your Terraform or Kubernetes manifests absolutely must be checked by infrastructure as code scanners like tfsec or checkoff. This is where infrastructure security perfectly intersects with application security. Catching those misconfigurations before they spin up in the cloud is absolutely crucial. You're ensuring base images are hardened, so no default passwords, no debugging tools left enabled. Secrets should be injected securely at runtime via HashiCorp Vault. And by utilizing blue-green or canary release strategies, well, if a security anomaly somehow makes it to production, you can roll the whole thing back in seconds.
Okay, we're on to Phase 4, the Watchtower. Let's get into maintenance and tooling.
Look, proper maintenance requires continuous runtime monitoring for unusual request patterns. You need to rely on centralized log alerts rather than SSHing into servers. Honestly, if a developer or an admin has to SSH into a production server just to read a log file, your architecture has a serious gap. You also need to heavily leverage automated pull requests for dependency updates so your libraries stay current with practically zero manual developer effort. And we need strict SLAs, like patching critical vulnerabilities within 24 hours. When an incident inevitably occurs, because they always do, you conduct a blameless postmortem. The goal isn't to point fingers, right? It's to figure out what happened and improve the pipeline so that specific attack vector is closed forever.
Finally, we reach the climax of our playbook, Phase 5, the automated engine.
So, the crucial point here is choosing the right weapons from what is a highly mature tooling landscape. We're talking about utilizing excellent open source and commercial options across every single category of testing: SAST, DAST, SCA, secrets, IAC, you name it. Whether you're using SemGrep for SAST, SNCC for composition analysis, or Checkoff for infrastructure, the landscape is incredibly robust right now. Most of these even offer fantastic free tiers to get you started. So there is simply no excuse for a modern engineering team to not be utilizing at least a few of these tools in their daily workflow.
When you actually integrate all this, it builds a true CI pipeline security gate, say in GitHub Actions. Let's walk through it. A single pull request is created. This sequentially triggers SemGrep for SAST, SNCC for SCA, and ZAP for DAST. This is what we call security as code. It's repeatable, it's enforceable, and it is totally transparent. A developer opens a PR and instantly, the code is checked, dependencies are scanned, and a preview environment is attacked. If a critical flaw is found, the build fails. The merge is physically blocked. Now, medium findings might just automatically generate a Jira ticket for the backlog, but criticals? They stop the line entirely.
We absolutely must enforce this automated pipeline because, think about it, if you have 50 developers pushing code multiple times a day, human security teams simply cannot keep up. Manual security reviews are a bottleneck from a bygone era. They just do not scale. Every single commit has to trigger a security check. You want to start strictly, fail to build on high-severity findings, and then adjust your rules as your team gains confidence. Automation is the only answer to ensure security is consistent and not just reliant on whether the security reviewer had a good cup of coffee that morning. As we wrap up this explainer, I really want you to take a hard look at your own workflows and ask yourself this critical question. If a developer accidentally commits an API key right now, like types out a production database credential and hits git push today, does the machine stop them? Or are you just crossing your fingers and hoping someone catches it in a code review? Take this playbook, pick just one security activity per phase to start with, and begin building an automated pipeline that truly defends your application from day one. Remember, perfection isn't the goal here. Continuous automated improvement is. Thanks so much for joining me on this deep dive.